Hello, guys. This is Frontend Tech Meetup. We have little bit of technical issues, but I hope it's working now. So this is a second online meetup, also known as Frontend Tech Show. And we are a dev community who excited about the modern frontend and the web platform. Today, we have two talks. Alexey Shpakov will talk about Jira Frontend Delivery, and Hexin Chen will talk about Flexbox. And if you guys have any questions, please just use the chat, ask the questions, prefixing your questions with the Q. And let us know where you're coming from, say hello, and yeah, just welcome everyone. And we are starting our first talk. Hello, Alexey, how are you going?
Yeah, doing all right. How about you?
Yeah, I'm good.
All right. So I guess I'll take it from here.
Yep.
So hi, everyone. My name is Alexey, and I work in Jira Frontend Platform team. Today, we'll have a look at how Jira Frontend is deployed and also have a look at some of frontend optimizations that we apply. So what is Jira Frontend? Jira Frontend has a lot of people contributing to it on a daily basis, as well as unique number of people who are contributing in general. We do at least 6 production deployments per day, and in general, we get about 10 minor incidents per month. So in order to properly handle those incidents, you want to have both rigorous incident process as well as a decent deployment pipeline. So let's start with process. Customers would love to use an application that never breaks. This might be achieved by having the code diligently covered with tests, following established guidelines, and detailed pull request reviews. However, as the application grows and evolves, it becomes more and more complicated to test all possible combinations of inputs to keep proper test coverage. PRs become more complicated, and guidelines may take some time to evolve. On top of that, running all the tests starts to take a significant portion of the application release cycle itself. And you could never discard the human factor. We all make mistakes. It's just a matter of time. For larger, complicated apps, incident mitigation becomes as important as incident prevention. In Jira, we embrace the fact that incidents are going to happen and learn to mitigate them. It is important to learn from past failures. We accomplish it by running incident post-mortem meetings for every major incident we have. This is a blameless meeting during which you identify the incident's impact, that is, how many production customers were actually affected by the incident. You also identify timeline and what were the actions to mitigate the incident and how we ended up resolving it. Probably the most important bit is trying to figure out the actual root cause for that incident. And I'm not talking the root cause for that particular incident. We're talking about the root cause that could cause the whole family of incidents. And the idea is once you identify that root cause and fix it, you're fixing all potential incidents and preventing them from happening in the future. And obviously, you want to come up with follow-up actions that will prevent this kind of incidents from happening again. Usually, you will have the priority action, which would be addressing the root cause, and maybe a couple of improvement actions. For priority actions, we have a rigorous SLO, and you are expected to implement them within a month once we created that action. There is a link on top. That is the link that describes the whole process online and in a bit more details. On top of that, in Jira, we follow you build it, you run it approach, which means that teams are in charge both coding features as well as supporting them in production. This includes having a 24/7 rotation schedule. The person on shift is expected to respond to monitoring failures within 15 minutes and be able to rectify the issue or escalate it further. You're not expected to fix the issue. Oftentimes, just mitigating it is good enough because, once again, it is 24/7 on call. And if you're woken up at 3 o'clock in the morning, you're definitely not in a mood to have a deeper investigation of what's going on. Every team in Jira Frontend runs a TechOps meeting. The goal for the meeting is to check service SLOs, discuss the ways we could improve them, follow up on previous actions, as well as have a chat with the person who were on call last week and get feedback from them. Because there could be some pages which were faulty. Maybe we need to tune up our monitoring. There could have been some actual pages that caused issues, and maybe we need to figure out how to fix those issues that caused those pages. Still, sometimes bugs do happen in production. When that happens, it becomes an incident. For every incident, there is an owner or incident manager. Incident manager is in charge of decision-making during the incident and external communication in case of a major incident. While smaller incidents might be handled by developers, major ones get a dedicated incident management person involved. The usual options for front-end-related incident resolutions are identify and toggle a feature flag that will allow us to turn off the faulty functionality. If that's not possible, we could probably roll back front-end to a known working version. Another option is to merge a fix in master and roll forward, that is, force release to be deployed to all production instances. And if none of those options are available, you would usually escalate higher up and involve more people in order to help you mitigating that incident. Let's have a look at different strategies we apply to front-end deployments in order to mitigate the incidents. Before we start, it makes sense to have a look at Jira Frontend architecture in a nutshell. This is like quite high-level explanation how it works. Essentially, whenever user opens Jira, a request from the browser goes to our web server. The web server performs page composition and returns result back to the customer. The composed HTML page will reference Jira Frontend assets deployed to CDN. All right, so the very first strategy we apply is called gradual rollouts. Even though we're using feature flags to release new features, sometimes people end up releasing bugs. That happens. In order to decrease their impact, we implemented gradual rollout. So the way it works is we split our customers in 8 different shards. We have 6 production shards, 2 shards per region, and 2 staging shards. The idea is to introduce an artificial lag between these shards receiving the latest version of the frontend. Every green build we have gets automatically deployed to both staging shards. Once release soaks on those staging shards for at least an hour, we promote it to Asia and Pacific region. This region contributes to approximately 10% of our whole customer base. Then it soaks for additional 2 hours in that region, and only after that we do promote it to the remaining US and EU regions. This gives us 1 hour of dogfooding before releasing the changes to first production customer, and extra 2 hours soaking time with a subset of production customers in Asia and Pacific region. The reason for picking Asia and Pacific region is because majority of Jira development is happening in Sydney, and that also means that if there are any issues deployed to Asia and Pacific region, we will be able to react quite swiftly. And it so happens that Asia and Pacific region working hours coincide with working hours of Sydney office. Some features can easily be feature flagged. Others may not be. For instance, it is hard to put a feature flag around a dependency bump or a build configuration change. For these kind of cases, we implemented what we call an alternative deployment. Essentially, the way it works is, apart from master, we also have a separate branch called old branch. By default, we build and deploy code from master only. However, in case we have this kind of changes which could not be feature flagged, for instance, in this case, we have React 16 bump, which is a big change and potentially a breaking one because it's a major version change. We still wanted to be able to feature flag it. So the way it works is we have a separate branch called release old. It has a separate pipeline that deploys the version both to staging and production. And then we have a feature flag located not in frontend, but on the web server side. So essentially, it is web server which decides which version of frontend to serve, whether it's the version that is deployed from master or it's a version that is built and deployed from old branch. And once again, as with any other feature flag, you have the capability of releasing it just to a subset of customers. So that allows you to get some signal from a subset of customers for a big change that could not usually feature flagged without breaking 100% of customers in case of any issues. And also, it allows you to use the flexibility of feature flags, because usually a dependency bump, in order to roll it back, you still need to go into your Bamboo builds, deployments, and initiate a rollback. With feature flag, it's just as easy as clicking a single button to roll it back. To start serving master. All right. Sometimes the issues could actually happen during dogfooding stage, and they could also be identified. So what happens then? When that happens, people are raising blockers. A blocker is essentially just a simple Jira ticket and a specified Jira project with priority blocker. What that means is, first of all, everyone knows that there is some issues happening on staging. And the second result is it blocks every promotion from staging to production regions. Obviously, whenever you are creating a blocker, you are also expected to verify that that issue that you have just identified in staging doesn't happen in production. Because if it happens in production, that's already an instance that you need to address appropriately. So people raise blockers that blocks any other promotions. That's how it works. So we used to have those promotions. The blocker blocks everything. So it takes a while we figure out how to fix the faulty build, and eventually we'll be able to come up with a solution. Say within 3 builds, we were able to commit the changes that would actually fix the issue. So at that point, we are ready to continue our promotion schedule. So usually people will say, like, okay, I'm going to close the blocker and restart the whole process. However, as I mentioned before, we're checking if the build has soaked for at least 1 hour in staging before performing the promotion. What would happen here is, because we had those 40 builds available, they could have already soaked for at least 1 hour and could potentially be promoted to production. That is quite bad. So what we do is we manually go to Bamboo instance, which is performing all the deployments, and we mark those builds as broken. That would tell our script that those builds should be discarded and never used for promotion. What would happen is the promotion script will promote the last green deployment, which was not faulty, and the next deployment it is going to consider would be the one with the extinguisher on it, that is with the fix implemented. And then we close the blocker and enable the whole pipeline of promotion of the deployments. Something else that we implemented is called frontend injection. It's not related to deployments. It's actually related to the process of developing functionality and making sure that it works properly. So we actually created a separate plugin for Chrome that allows people to inject their local version of frontend into a staging version of Jira. The way it works is it passes a custom HTTP header into a web server. Once web server reads that custom HTTP header, instead of serving frontend from a known production location, it will serve it from the location that is specified in that frontend in that HTTP header. Obviously, we have multiple services we could inject. So here you could see we have frontend fragments. That is essentially the frontend SSR service. So server-side rendering could also be injected manually from your local or from another service that you deployed separately. And also we have frontend server reverse proxy that is used as a frontend server as a frontend server in front of all the frontend. On top of that, for every staging build, we are building the production grade assets and deploy them to S3. What that means is that it allows people to serve those assets from that S3 location. So you don't even need to run your local branch and your dev server to serve it and to show it to your friend or a colleague. You could just send them the link to your to that location for your branch, and they will be able to see the exact changes that you did in your branch in staging environment of Jira. All right, so far so good. We've covered the process of mitigating incidents and our deployment pipeline. Let's look at different strategies we applied to frontend let's look at different strategies we apply to optimize our frontend. So the first, quite simple and obvious one, I hope it doesn't make any sense for you, but if it does, please follow it. That is, please use CDN whenever you are serving front-end assets to customers, because CDN will essentially allow you to serve your assets from the nearest edge to your end customers, thus decreasing latency, and will also decrease your bill for traffic. And also, please use HTTP2 if you're not using yet, because it will allow you to speed up your front end by using a lot fewer connections than HTTP1 does. So the other obvious thing to do is caching. It's one of the easiest way you could improve page load speed. In Jira, we set cache time for assets to 1 year and add immutable directive. It tells browsers the contents of the file will not change within the cache time. As a result, browsers will save extra re-evaluation request checks, checking for updates. Once you have these cache rules in place, it is critically important to make sure that you are never getting assets collisions. To avoid collisions, we hash file contents and put that hash into the file name. Unfortunately, by default, Webpack uses pre-minified file contents for cache generation. And we actually had an issue when the minification was actually causing us trouble. So we developed a separate plugin to perform hashing after uglification. It's called Webpack plugin hash output. Another important concern about cache is how frequently it gets invalidated. One of the options is to decrease invalidation time by using named chunks in production. The next version of Webpack will actually have deterministic chunk ID generation option that will improve file content stability even further. Brotli is a compression algorithm from Google supported by all modern browsers. It provides up to 30% bundle size reduction compared to gzip. There is a small caveat though. It takes up to 10 times more time to perform the compression. Another unfortunate issue is that Amazon's CloudFront doesn't support it out of the box. And we in Jira happen to use Amazon CloudFront. However, you can use Amazon Lambda to implement it. Or use a more up-to-date CDN, because I do believe that every other CDN outside, other than CloudFront does support it already. Modern bundles. It's a popular technique that suggests that we can achieve performance wins by serving less transpiled versions of front-end bundles to the recent versions of browsers. In Jira, by default, we transpile and polyfill all our JavaScript code to make sure it will run well on all the browsers we support. This usually means assuming as few browser capabilities as possible. And keeping in mind that we are still supporting IE 11, that's quite few browser capabilities. As a result, we apply a lot of code transformations and polyfills. What we could do instead is produce two separate bundles, the default one for the less capable browsers and the modern one for the more recent browsers. Then, at runtime on a web server, we can pick one or the other based on browser making a request, for instance, by sniffing user agent string. In case of Jira Frontend, we're serving modern bundles to 95% of our users. And according to our statistics, this actually improved time to interactive by 2 to 3% for 50th percentile of our customers. Code splitting. Code splitting is another important and useful technique in order to make your web page a lot more performant. Oftentimes, the user doesn't need all the code of your application straight away. Code splitting allows you to split non-critical part of the code into asynchronous bundles to be loaded on demand. This decreases the amount of code that needs to be downloaded, parsed, and executed before your application becomes operational. In case of Webpack, this is accomplished by a dynamic import. On top of that, starting from Webpack 4, I think 4.1.6, but latest version of Webpack 4 definitely supports it, you could provide a magic comment that will output a preload link in the head of the page. On finding this link, browser will start downloading asynchronously that bundle in parallel with the main one, thus speeding up your page even further. The idea behind streaming is to be able to return the page to the browser in chunks, as soon as the server has all the information needed. This may make little sense for pages which are rendered on client side only, and are usually quite lightweight. However, if your application implements server-side rendering, streaming could help speed it up even further. In case of Jira, we output the first chunk containing preload tags as fast as possible. At that moment, browsers start downloading assets, and the page will use later on while the web server actually performs the server-side rendering. As a result, instead of simply waiting for server-side rendering to finish, browser already performs useful work that it will be able to leverage later on. In Jira Frontend, we rely on Atlas-Kit components, a set of React components following our Atlassian design guidelines. Every component is versioned individually and can depend on other components. This will usually not cause any significant issues until the number of components grows significantly. We currently depend on 137 Atlas-Kit components, 137. That's a lot of components. Let's explore the issues that you might get at that scale. So there are obviously primitive components like buttons and complicated components or complex components like select, which could depend on the primitive ones like button. So the way you would implement them, the way you would install them is simply by running yarn add button, say version 100, and yarn add select version 101. However, the issue is that if they do not match exactly the dependencies, say the select 101 could potentially depend on button version 101 as well, the structure of node modules you will get would look like that, which means you'll have button version 0 on your root level, and select 1.0.1 will have its own version of button underneath. As a result, and that would be how your yarn log file would look like. As a result, when bundling the application, Webpack will end up putting both versions of the button in the resulting bundle. Fortunately, we have semantic versioning that tells us that button version 1.0.1 will probably be able to meet both requirements for button that we have. That is button 100 or higher and button 101 or higher. And ideally, you would want Yarn to be smart enough and deduplicate these dependencies. Unfortunately, Yarn will do that for you just once, the very first time Yarn log file is generated. All the subsequent updates, it will not perform any deduplication. In order to fix it, we developed a library called Yarn deduplicate. So those are the issues that we are trying to fix. This is the way you're running it. Essentially, you could just run npx yarn deduplicate, and then we'll run yarn install. What that library does, it actually goes into your yarn log file and deduplicates all the dependencies matching the same semantic versioning. So in this case, the produced node module structure would look like that. So you would have just a single version of button, and that would be version 101, and just a single version of select, which with version 101 as well, and it will not have any private node modules underneath. And the yarn log file will look like that. Essentially, that means that we are resolving button version 100 or higher to version 101, and at the same time, we're resolving button version 101 or higher to the same version, which is 101. So that would work in case you have root level dependencies which are compatible with your transitive dependencies. However, the things could get worse. There could be cases when your transitive dependencies do not match semantic version of your root dependencies. For instance, you could imagine a case like that. You have a button version 1 on your top level, and then you have two complex components that depend on different versions of button, but they depend on the next major version of button. For instance, you have select version 2 or higher and combo version 201 or higher. Obviously, we'll still run yarn deduplicate, and what would happen is this yarn deduplicate will allow us to make sure that both select and combo are using the same version of button. However, unfortunately, they're still duplicated. You could see we have version 1 on root level, and we do expect it to be there because in the whole code base, we do rely on version 1 being there. However, select 2 and combo 201, although they do depend on the same version of button end of the day, they still get it duplicated. And when you run Webpack, you still end up bundling both versions in your bundles, which is not good. To alleviate this issue, we have implemented a separate plugin for Webpack, which is called Webpack Deduplication plugin. Whenever Webpack attempts to resolve a transitive dependency, this plugin memorizes the returned path. And the next time Webpack requires same version of the same dependency, the plugin will supply the original memorized path instead. This allows Webpack to reuse already resolved dependency instead of duplicating it, which will mean that the actual build will be faster, and obviously the resulting bundles will be smaller, and they will be a lot more performant for your front end, for your customers, because the browsers will not have to parse and evaluate button version 2 or 1 twice. Here's a bunch of useful links that I shared during my presentation. And thank you very much. I hope you'll be able to use some of the techniques I explained in my presentation, and I will be ready to answer your questions after the second presentation of the evening. Thank you.
Hey, Alexey, thanks for great presentation. I hope you guys enjoyed it. And if you have any questions, please just ask in the chat. And we come back to the questions after the second talk. Basically, we'll have like a panel discussion. We will answer all the questions and stuff like that. So yeah, just prefix your question with a Q, then your question and question mark. All right. Thanks, Alexey. See you in a couple of minutes. I guess like 20 minutes probably. And I want to welcome to the stage Hexin.
Hi.
Hey, Hexin, how's it going?
Hi, good. How are you going?
Yeah, we are great. Let us please, what you gonna talk today?
Hi, everyone. Today, I'm going to give this talk about Flexbox. So should I start?
Yep, go ahead.
Okay. Let me just do a quick introduction. My name is Hexin. My name is Hexin Chen. I came from China about 5 years ago and currently work at Skychute as a junior software developer in Sydney. My focus of everyday work is front end, which is also my passion. I like to build well-functioned, visually pleasing, and user-friendly UI. And I also like music quite a lot. I'm currently taking an online orchestration class because I love epic orchestral background music or video games and anime. So hopefully I can be a digital orchestrator when I finish the class and create something epic as well. Let's start the topic. Today, I'm going to briefly talk about 3 parts: why we need to use Flexbox, and how do we use Flexbox, and what are the limitations and workarounds of Flexbox. So just to briefly give a definition, Flexbox is short for CSS Flexible Layout. It's a CSS3 web layout model. To summarize, it basically deals with 2 issues. 1, distributing space. 2, distributing space and aligning items in the container. First, let's talk a little bit about why we need to use Flexbox. There are a bunch of reasons, but for me personally, these are the most fascinating reasons. First of all, it's supported in all major browsers. As web developers, we really need to make sure that the features that we implement are compatible with different browsers. Secondly, nowadays we have a bunch of cool web development frameworks, including React, Angular, and Vue. But deep down, they're just using HTML, CSS, JavaScript to change the DOM elements, right? No matter what framework you use, it's almost inevitable that you deal with layout and those that has very similar idea with Flexbox, such as Angular, FX layout. In fact, you can choose not to use those layout frameworks at all and just use CSS Flexbox and don't need to worry about the syntax. Third reason is to manage layouts change in different devices. You don't want to write a totally different HTML template because you developed a page for desktop and now you need to do the same thing for tablet and mobile. You don't need to do that. You can use Flexbox with minimal effort and codes. Another reason is surprisingly centering. The other day, I saw a meme about that. As a web developer, expectation is that we build fancy, beautiful, user-friendly UI. Reality is that we spend 2 hours trying to center an element. It's a little bit exaggerated, but why is centering such a pain? Let's look at the life before Flexbox and what do we do in order to center an element? If we want to center this horizontally, it's relatively easy. Just give it a margin 0 auto, which means that you give it a 0 margin both in the top and bottom, and let it calculate the needed margin on the left and right. You can also do it like this, give it a 100 pixel margin in the top and bottom, and give an automatically calculated margin left and right. But if you want to do it vertically, here we need to use position property and set the parent and child component to absolute and give the child component a top 50% to align it from the halfway. But this is not even the result we want. As we can see, the 50% is considered for the top border of the child component. But we want the middle of the child component to have a top 50%. In order to do that, we have to give it a negative margin top 50%. This is 50% because it's half of the height of the child component. And if you want to center them both horizontally and vertically, you need to combine these two approaches. But what if in the future we need to change the size of parent or child component? Do we have to go over this negative margin top again? So Flexbox is here to solve this. Okay, how do we use Flexbox? I'm sure that when you do the debug in the inspector, you have noticed sometimes there are some auto-generated CSS, such as something like this. It's not quite self-explanatory, is it? Let's go through some basic usages of Flexbox next. First of all, we need to learn an important concept: main axis and cross axis. And this is defined by the property flex direction. So if we want to align items in a row like this, we set the flex direction to row or row reverse. Then the main axis will be horizontal. Similarly, if we set the flex direction to column or column reverse, the main axis will be vertical. Cross axis is simply the opposite of main axis. If the main axis is horizontal, cross axis will be automatically vertical, and the other way around. Another thing we need to keep in mind is that in Flexbox, we never see syntax like left or right. Instead, we will see start and end a lot. The reason is that Flexbox doesn't assume the writing mode of the document. If the flex direction is row and I'm working in English, then the start edge of the main axis will be on the left. The end edge on the right. If I were to work in Arabic, then the start edge of my main axis will be on the right and the end edge will be on the left. In both cases, the start edge of the cross axis is at the top of the flex container and the end edge at the bottom, as both languages have a horizontal writing mode. After a while, thinking about start and end rather than left and right becomes natural and will be useful when you're dealing with other layout methods such as CSS grid layout, which follow the same patterns. So next up, flex container. To start using Flexbox, you just simply give the parent container a display flex. Then this container will be flex container. All the child components inside it will be flex items. Let's see some code examples. So as you can see, the parent component, the class is called row, and I just simply give it a display flex. And I set the flex direction to row. So 1, 2, 3 are aligned from start to end. And I set it to column. It looked like this. It will be aligned from the top to bottom. And This is how row reverse. I set the flex direction to row reverse. So 1 to 3 will be aligned from the end edge of the main axis if the main axis is horizontal, sorry. And also column reverse is pretty similar. 1, 2, 3 will be stacked in this way, in this direction. Okay, so next we see this useful property called flex wrap. A lot of the times when we set the fixed width of a parent component, but we have so many child components inside it, how can we align them nicely without exceeding the border of parent component, just like the automatic line breaks of a long sentence? So flex wrap is here to help. Let's see some code. So here, so the container, the width of this container is 300, but each item is 200. So there's no way that all these items can be aligned nicely in the same line. So as you can see, by the way, I set the parent component with the red border and all the child components with the purple borders. So as you can see, if I don't do anything, just let it be default behavior, like starting from 2, they will already exceed the border of the parent component. So simply in order to solve that, we just set flex wrap to wrap. And you can see that from item 2, it will automatically, just like a line break of a long sentence, it will be wrapped nicely to the next line. Okay, so this is flex wrap. It's pretty useful. Now let's look at another commonly used properties of Flexbox: justify content and align items. These are the factors that we can set for align items, and these are the factors that we can set for justify content. If this is confusing, we just need to remember that justify content deals with main axis, and align items deals with the cross axis. Let's see some code. So here I have this big parent component and have 3 child components, and item 2 is a little bit longer than the other 2. So justify. By the way, the main axis is horizontal because I set the flex direction to row. And so justify content deals with the main axis, which means that now I set it to center. So all these 3 items will be grouped in the center in the direction of horizontal. And align items, I set it to center. Now you see that the whole group vertically, they're aligned in the center. But we can also see other effect that comes with justifies content to see how they look like. So I think these factors are pretty self-explanatory. If I set it to flex start, as you can see, they're grouped together and be aligned from the start edge of the same line of horizontally. And if I comment that out and set it to flex end, they will be grouped and aligned at the end edge of the line. And there are also other things like space between, look like this. I will go through these 3 later. Now let's just see their effect. So space around look like this. And space evenly look like this. By the way, align items. So you can also do stuff with align items, and I think they are pretty similar. So flex start, align items, basically that they just be aligned from the start of the vertical line. And similarly, let's see, flex end, they'll be like this. By the way, stretch as align items is the default. So as you can see, all the items except 2. Why 2 is not stretched? Because I set it to, I give it a set height. So if it doesn't have a set height, 1 and 3 will be stretched all the way to the limit of the parent component. Okay. So just now we see some space between space around and space evenly, but they all look like they just distribute child components nicely in the main axis. What's the difference among these 3? Space between is easier to understand. You will just align the first element from the start edge and then align the last element in the same line at the very end edge. Then the rest of the components will share the middle space. And space around, on the other hand, in this example, there are 3 items, so horizontal space will be divided into 3, and each item will be centered in their own space. Space evenly is a little bit tricky. It looks similar to space around, but we just have to recall that when we were in primary school, teacher taught us about the concept of dots, line, and line segments. Imagine we have a line and 3 dots, and we want to divide the line evenly with 3 dots. How many line segments are there? 4. So similarly, if we have 4 dots and we want to divide the line evenly with 4 dots, we then will have 5 line segments in total. So space evenly is just to treat the horizontal space as the line, and then treat items as the dots to evenly separate it. So when you see space around and space evenly, don't need to feel confused. Just think about the line segment. Of how to use Flexbox, last but most importantly are these 3 beauties: Flex Grow, Flex Shrink, and Flex Spaces. Like we mentioned, why we need to use Flexbox. A well-functioned website should support different devices. In all different devices, all elements in the page should behave in an elegant and flexible way. Say you have a page looks beautiful in a 4K desktop monitor, but when you open the same link in an iPhone 5, there are supposed to be 3 items, but you can only see the first one because you give the items a width that is too big and the screen is just too narrow for them. But should we set a different width for an item for each single possible device? We probably can't even cover them all. And some people sometimes just like to shrink and expand the browser to test your responsiveness. We all came across a QA doing something like that, right? Just shrink and expand the browser and tell you, hey, your thing is not not responsive. It would make sense that in a larger device, we want the same items to grow to fit the container. And in smaller device, we shrink the same items so that all of the items can display in a predictable way. That's why I introduced Flexbox, FlexGrow, FlexString, and FlexSpaces. In order to understand that, I have to talk about an important concept: positive space and negative space. In this example, the flex direction is set to row, which means that the main axis we're talking about is all horizontal. See, the first container, the whole pixel in main axis is 600 pixel, but each item is only 100 pixel, which means that in total, they only take up 300 pixel and there are 300 pixel available. This available space is called positive space. Similarly, negative space just means that, see this second example, the whole pixel in main axis is 200 pixel, but each item is also 100 pixel. That means that the total space that they need is 300 pixel, but we lack 100 pixel for them. This lacking of 100 pixel is called the negative space. We use flex grow when there are positive space and use flex shrink when there are negative space, okay? Flex grow property will not have effect if there is no positive space. And similarly, flex shrink will not have any effect if there is no negative space. Let's see some code. Okay, so this is the example in the slide. So in the example 1, so by default, I haven't set the flex grow, but a very common, so as you can see, they just behave in their natural way because I give them the set width to 100 pixel. But what if, yeah, let's say you develop this page, but now your customer is using a 4K desktop, which is pretty large. And you want, but the fact is that you want each single item to take as much space they can so that they don't appear as so tiny in like something like a 4K monitor. So this is a very common practice. We give each of them a flex grow 1. So now the problem is solved. So what does this 1 means? We will come back to it. So basically, I set them, all of them, the flex grow for all the item to 1, which means that, so the 1, 1, 1 is just ratio. They're not the actual pixel or something. So they look a little bit confusing, but actually we can just recall the ratio calculation when we were young. So I just set 1, 1, 1 as flex grow to all of them. So which means that the total parts to grow is 1 plus 1 plus 1, which is 3. And the total positive space to grow is 600 pixels minus the total of 300 pixels, which means that we have 300 pixels, which means that the space each item gets additionally is 300 pixels, and then they get 1/3, 1 part of 3 parts. So each item will get another 100 pixel. So at the end, each item will be 100 pixel plus 100 pixel and 200 pixel. So altogether, they add up as 600 pixel. So problem solved. And sometimes another common practice is that sometimes not all items are treated equal. Sometimes, I don't want to comment this out. Sometimes you can treat them a little bit differently. Say, so if I set 1 to 1 and set 2 to flex grow 2 and item 3 to flex grow 3, as you can see, the item 3 just grows a little bit faster. And how come they behave in this way? It's also similar. It's also the same idea. So the total parts now is 1 plus 2 plus 3, which is 6 parts, and it's still 300 pixels for growing. But now the actual space that each item gets is that for item 4, it only gets 1 part of 6 parts, which is 50 pixel, and item 5 is like 2 parts of 6 parts of 300 pixel, which is 100 pixel. And item 6 only gets 150 pixels. So all together, they share this available 300 pixels. So another thing is that negative space. So sometimes we need items to shrink. In this case, we need items to shrink. So let's say now our scenario is that this displays nicely in the 4K monitor, but we are now actually testing them on an iPhone 5. So let's see this, the next property, flex shrink. So if I comment this out and give all of them 1, 1, 1, they will shrink like this very nicely. And why they behave like this is very similar. So now they also share 3 parts of the negative space. And the negative space is 100 pixels because 200 in total, and each of them is 100 pixels wide. So now for each item, this is the amount of space that each of them needs to shrink so that they can all fit. So what if we do something similar, that we treat them a little bit differently? We give Then we give item 5 a flex string 2 and item 6 a flex string 3. As you can see, item 6 just shrinks so much more than item 4. And it's very similar as well. Just that now the total parse is 6, and this is still that much on space that we need to shrink for. But now each item is also 100 pixels, and now it needs to shrink one part of 6 parts. So this is how much item 4 needs to shrink. And similarly, this is how we get the actual width of each item. So yeah. And so so we use flex. Sorry. Oh. Oh, sorry. So a very common pain when we debug in the inspector is that we thought we set the width of an item to 500 pixel, but it still doesn't quite look like 500 pixel wide at all. And I do notice that there are some auto-generated CSS because I'm using some design system layout framework, and I put flex something somewhere because I copy and paste the example from the documentation. It's because flex basis is overwriting your set width. So which brings me to my next question, who actually determines the size of an item? Here's a very ugly tree illustration. So if a flex basis is set to auto, and does the item has a width set? If so, the size will be based on that width. So if the flex basis is set to auto, but the item doesn't have a width set, then the size of the item will be based on the content. So a 3-letter content will be wider than a 1-letter content. So in another case, if a flex basis is not set to 0, so we check if the flex basis is a length unit. If yes, then it's based on that flex basis. If no, it means that the size is not taken into consideration for the space sharing calculation. So I just want to quickly mention about the 2 commonly used shorthand. Flex flow simply combines flex direction and flex wrap. Let's quickly check the code. So we just learned that. So these 2 lines are basically equals to this line. Oh, so sorry. My bad. Shorthand examples. So flex direction row and flex of wrap or no wrap can be simply combined to a flex flow row no wrap or wrap. So as you can see, they have the similar behavior. And another shorthand that I want to talk about is flex. So a lot of the times, often we need to set, just a second. So a lot of the time we need to set all the 3 properties, flex grow, flex string, and flex basis. A common practice is that we combine them into one line, flex, and the 3 factors represent flex grow, flex string, and flex basis. So let's not forget the order. So for example, if I set all of them, we can just simply give each of them this one line. This represents that grow is 1, string is 0, and flex basis is auto. So it just needs this one line, so we don't need to like write 3 lines for each item again. Okay, so another trap I really want to mention is 0. So what do you think will happen if we set the flex spaces to 0? Do you think that it will set the width to 0 pixel? No, it actually will nullify flex spaces. Will let flex spaces have no effect. Let's remember, for all flex grow, flex string, and flex spaces, we can only use positive numbers. 0 or negative number will not have effect at all. So in this case, if you set flex spaces to 0, you're not setting the width to 0 pixel. You're just passing the control of the size to the set width again. So if there's no set width, then the size of it will be controlled by its content. So this is just a trap that I really want to mention because I got trapped a lot. At last, I want to briefly talk about the Flexbox is not superhero that does everything for your layouts. It has its own limitation. For example, a few weeks ago in my job, I need to create a masonry layout. Basically, I want the order to be from start to end, as if my main axis is horizontal, but I also want items to be grouped in columns. What do you think the solution should be? So you might think that, okay, I just need to set main axis to horizontal so that I can maintain the right order. But there will be this awkward gap because the height of each line is determined by the highest item, such as number 1. Then you might think, okay, I'll set main axis to vertical so that there's no gap, but then the order will be vertical as well. So in this situation, simply using Flexbox is not enough, but we can combine Flexbox with selector to solve this problem. Let me just quickly introduce a Flexbox property that is not as commonly used, order. By default, flex items are laid out in the source order. However, the order property controls the order in which they appear in the Flex container. So technically, you can give any item any order you want. Then they will be sorted in their line according to their orders. So now, as we can derive some rule from the order. So we want the order to be like this, but I want them to be grouped like this. As we can see for this column 1, all these items, this 1, 4, 7, 10, they can be represented as 3m plus 1. And similarly, this column 2, these numbers can be represented as 3m plus 2. And column 3 is 3m plus 3. And selector nth child, by writing it like this, we simply represent all the items in column 1 as 3m plus 1 and give all of them an order 1 so that we make sure that they're grouped in column 1. So similarly, we do the same thing for column 2 and column 3. So this is a really nice workaround that I discovered online when I came across the limitation of the Flexbox. Okay, so that's basically it. My talk about why we need to use Flexbox, the basic usage of it, and the workarounds of Flexbox when we find its limitations. So thank you very much for today.
Thank you, Hexin. It was a great talk. I hope, guys, you enjoyed. If you have questions, please ask the questions in the comments. And Alexey, welcome back. Hello.
Hello.
So, hey, guys, let's just look at the questions, see what people commenting. So, yeah, someone commented cool. So, which is good. I'm not sure who was it related to. Cool. Was it related to Hexin or to Alexey? I think to both.
So I guess I can start with Jira questions. I found two questions. The first one was about the total size of Jira bundles. The total size of all minified, non-compressed is 228 megabytes. I just checked it. That is the exact numbers that we have. Obviously, we serve it broadly and gzipped for browsers that do not support broadly. And that number goes down by approximately 60%. So in total, if you navigate to all pages in Jira that are possible, you will end up downloading approximately, I would guess, 80 to 100 megabytes of stuff.
Is it like total build, the evergreen browsers and all the browsers, right?
So I'm looking at modern browsers. So for older browsers, I think the total amount of assets is 250. So we are talking about 22 megs difference. So approximately 10% difference. And also for those browsers, for older browsers, you do a lot more transpilation, so the resulting assets would be slightly slower, because instead of relying on native browser behavior and native browser capabilities, they would be relying on JavaScript and transpilation instead.
Okay, so there is a question to Hexin. Will you guys consider browser compatibility when using Flexbox? So I think the question is related to like the old browsers, probably like old IE, they won't support the Flexbox, right? Like server.
Yes. So CSS Flexbox model is quite supported in major browsers, but there are some certain properties such as like, in Flex basis, you can set it to auto or length unit, but you can also set it to content. And this content means that the size of it will be based on how long the content will be. So for example, like if the element is hello, it has 5 letters, but if your another item is a longer word, it will take more space. But this content is actually not supported in all browsers. So there are some things we need to consider. So that's why I didn't mention the content as flex spaces, because it's not supported in all major browsers. Yeah, but most of the properties are quite supported.
Right. And what would you do, like, say, if you want to support really old browser? Would you polyfill, or what would you do?
I haven't quite thought about that. Really old browser? Are we talking about like IE?
Yeah. Okay, come on. Who's supporting the old browsers, right?
Okay. We're still supporting IE 11.
Oh, okay. Only these guys.
But that's something we need to consider for sure.
Right. Okay, let's see another question to Alexey. Can a developer spin up a full-fledged isolated Jira environment in the cloud for each feature they are working on? Do you have a CD for it?
Yes, developers can do that. Essentially, they go to a normal page where you would order a Jira Cloud instance. I think we're passing some specific parameters, and we're also checking that the request comes from our local Atlassian network. But essentially, people will go through exactly the same process as every customer would go in order to order a new instance of Jira. And they will end up getting their private instance in staging. And they could have as many instances as they like. Then probably another question is how close it is to production. And that's a tricky question. We were thinking about it a lot. The question, it is related to feature flags, because we have so many different experiments enabled, disabled under different conditions. There is no real notion of production environment. Even in production, on different charts for different customers, you end up having certain features enabled and certain features disabled. So speaking of that, you have full control of the feature flags for your own environment, and you could configure it to be as production similar as possible, whatever is the definition of production for you. Oftentimes in staging, you have all the latest feature flags enabled, which are not yet rolled out in production. If for some reason that intersects with your work and you don't want to have it enabled, you could just disable that particular feature for your private instance. But yeah, essentially you could spin up as many instances in staging as you like, and you could configure them to be as similar to production, whatever is the definition of production in your case, as possible. For separate continuous delivery, no, we don't have it. Essentially, that would just work similarly to every other Jira Cloud instance that you would order online, and this process doesn't take as much time.
Right. Another question to Alexey. How you handle incremental builds?
So probably if you're talking, are you talking increment? Okay, I would need some clarification.
Yep,
I'll
yep,
try to
exactly.
answer both questions. So one thing is if you could be talking about incremental builds during your development, as in you start up your dev server and then you do some changes, and this dev server updates things on the fly. And the second one is trying to leverage caches and previous build results as a part of continuous delivery.
Exactly that. Yep.
You're talking about the last one?
Yep, the second one.
So we don't really do that much of it. So all we do is we preserve caches between compilations. So there's a lot of tools like Babel, Webpack, Jest, Stricter. I think ESLint might be as well, which preserve their caches in node modules .cache folder. That's a convention that a lot of companies are following and library developers. So we preserve that cache between our builds. That allows us to get fast uglification. So Tersa, we use Tersa, and Tersa does store its cache. And it also helps us get better transpilation because Babel leverages that cache. For Webpack itself, I don't think it makes a lot of use of that cache. However, in the 5th version, which is still in development but quite close to getting released, they do a lot of improvements in terms of caching between compilations, and we'll definitely start leveraging that once we migrate to Webpack 5. Another option to consider is Parcel, which is a separate bundler, and it's highly supported by Atlassian. It's still work in progress. I think the folks are going to release the version 2 once it's done. I don't know the exact dates, but they pay a lot of attention to incremental builds and make sure that you are able to leverage as much caching as possible. So that might be another consideration for you.
Right, and say like you got this feature request to change the color of a button somewhere. So how long would it take to actually deliver this change to production?
Yeah, so I can actually answer that exact question. That is actually one of the SLOs for my team. And what we do is for every branch, we run a branch build to make sure that we are passing all the verifications. Then once the branch is merged into master, we run master build, once again, to make sure that we are not back into production. And once that master is green, we'll eventually run the deployment to our first production customer. Those 3 parts, we combine them together, and we actually use that number as SLO for my team. I think last week this number was hovering around 70 to 80 minutes mark. So like in the simplest case possible, you do a change, you run your build, your PR gets automatically approved, you'll get your changes to production within 75 minutes on average.
Okay, right. Question to Hexin. When should I use a CSS framework if I know how to use advanced CSS?
I think, personally, there's no right or wrong timing, but at least in my company, so when I just joined my current company, my coworkers use Angular FX layout, but I just prefer to use CSS because I was just more familiar with CSS, and I believe using CSS can just achieve what I want. But my company is quite supportive of that because I think CSS is supported, and as long as you know what you're doing and the framework is going to be compatible, I think there's no definite answer of which framework I should use. I think as long as your teammates are okay with the code that you write, I think that's okay. At least that's the situation in my company.
Right. Yeah, I hope it's answering the question. Another question to Alexey. What does Jira Frontend team use for end-to-end tests?
Okay, I think there are 2 parts to it. So first of all, whenever people are talking about testing in general, there's a notion of testing pyramid, which is like you have a lot of unit tests, you have fewer functional tests, you have even fewer end-to-end tests. But you could also think about it a bit further and talk about the hourglass of testing. So once you do testing, then that middle part is the deployment, and then you do monitoring in production. So speaking about end-to-end tests, in Jira Frontend, in particularly, we're using Cypress, and we are using Cypress on top of storybooks. So we have plenty of storybooks. I think we're clocking around 6,000 storybooks. What we do is in Cypress, first of all, in storybooks, we mock all the dependencies. So whenever you're running storybook, you do not talk to any backend. All the requests that you do, they're already mocked there. So what we do in Cypress, we navigate to those storybooks, and we perform different actions. What it allows us to do is to make sure that our tests are a lot less flaky, because we do not have any dependency on the backend. That removes a lot of maintenance burden there. And the other thing is, because we're using storybooks, that allows us to mount components, probably larger components. Definitely, you're not going to do end-to-end testing for button, but it allows you to mount those larger components in isolation as well, and allows you to test them properly. So that's the testing part. Now, talking about the monitoring part, we have a separate tool called Pollinator. What it does is it actually runs WebDriver or Cypress tests. So you could pick whichever you like. We have a bunch of WebDriver tests, but we are migrating to Cypress as well. What it does, it runs Cypress tests on real instances of Jira. Probably you are talking about a custom instance that you spinned up so that you do not affect any customers. And what it does, it just tries to run the goat path for the most common functionality. Say you want to create a project or you want to create an issue. So you will write a Cypress test that would perform just that. And what the Pollinator does for you is it runs that test every minute. And whenever it has, it depends on how you configure it, but usually it would be like, if you have failing tests that are failing 3 times in a row, that would issue a page that would page you, your people as a person on call, and you'll have an incident to resolve. So that's not exactly end-to-end test. That's more for a monitoring side, but we are still using Cypress, and we are using real-time Jira there. So that is like more real-time integration things that we do have. Something to note that we have a lot fewer of those pollinated tests, pollinated checks, than we have for Cypress tests before we deploy stuff.
Right. Okay, another question to Hexin. What is the best place in the web to learn Flexbox CSS?
Oh, I think, yeah, I actually linked 2 games that I find really useful. Can you share my screen? If not, I think
Actually, I mean, but guys, actually, I also saw someone ask about the links and stuff. So everything we will be sharing the links. So maybe in the next half an hour after the event, check out the description on the video stream. So we put all the links into the description, as well as we send out all the links and follow up or through the meetup group, and also we will tweet it and link it in it, and we will do whatever we can. So basically you'll get all the links. All right, so what was the answer to this one?
Yeah, so these two Flexbox Zombies and Flexbox Froggy, I find them really interesting when I learned how to use Flexbox. So yeah, I recommend these 2 games.
Okay, guys, these links you'll find on the slides after the stream. Another question to, I guess, Alexey. Can Cypress run end-to-end tests across browsers?
Starting from version 4, they actually added support for latest Edge, which is technically Chromium behind the scenes, and also for Firefox. So probably the only thing that they do not run it for is Safari. So that is one off. But other than that, you could use Chrome, Firefox, and Edge in Cypress, starting from the 4th version.
Right, but say if your client's using Safari, right? So is there any way you can somehow come up with some solution to test it, or it's not possible at all? Using Cypress.
We haven't invested a lot in that, simply because the percentage of Safari users is quite low. Something that I could think about is, right now in Jira Frontend, I'm working on visual regression testing. And the vendors that we are using for that, does allow us to do tests in Safari. So something that we could, a way to alleviate that issue would be to introduce visual regression testing in Safari, which is what we are going to do. Other than that, I could not think of a way to run end-to-end tests in Cypress for Safari. Sorry.
Right. How easy it is to write? Actually, I used to talk with someone last week, I think, and they said they write in the plugins for Jira. I didn't know that actually you can write the plugins. So as far as I understand, like anyone can write a custom plugin for Jira. Is it true?
So I don't think I'm the best person to answer that question. I can just explain you my understanding. So first of all, there are two types of Jira. There is Jira Server and there is Jira Cloud. So Jira Cloud is the one that people are using in cloud. Jira Server is the ones that you install on premise. Jira Server does have support for Java-based plugins, and you can definitely write that. If you're talking about Jira Cloud, I believe we do not support plugins. What we do support is we support Marketplace. So what you could do is you could write your extension in Marketplace. I don't know the details, but you could probably Google Atlassian Marketplace, Atlassian Jira Marketplace, something like that.
Right.
And there's probably a bunch of requirements that you need to meet in order to qualify. But once you do that, you could just write your own extension as a Marketplace add-on. If you're talking about APIs and different capabilities there, I'm definitely not the person you need to talk to, but there should be plenty of documentation available online on that topic.
Right. Yeah, I actually didn't know that you can do that, but yeah, that's awesome. All right, so guys, I think we're running out of questions. So I think that was great discussion. Thank you guys to answering all that, and thanks for your time to preparing the talks. I think, it was great talks and very informative. And yeah, again, we will be sharing the links. So everyone who watching the stream, we will share the links pretty soon. So yeah, I think we are finishing. So thank you everyone who came today, who joined the stream, and see you next time.
Thank you. Thank you for having me.
Thank you. Have a good day or evening, wherever you are. Bye.
Subscribe to the channel, hit the like button, and see you in a couple of weeks, I guess. Bye.
Thank you. Bye.